Hello everyone. In this video, I will be showing you how to model a well using Prosper software. First, we go to options to open system summary. On this summary or system summary is where you define what exactly you want to do, the type of well you want to build based on the properties, the reservoir data, the fluid data, and then is it a natural flowing well? This is where you choose. If it is artificial lift well, you choose the type of artificial lift. Is it gas lift or pumping system? If it is gas lift, is it intermittent or continuous gas lift? So basically we have two types of gas lift or two types of artificial lift. We have gas lift and we have pumping system. Under gas lift, we have two types of gas lift. We have continuous gas lift and then we have intermittent gas lift. Under pumping system, we have several types of pumps from ESP, electrical submersible pump, down to sucker pump. So, but now we want to analyze the performance of a natural flowing well. So we leave it as none and we want to defloat this oil and water, and it's black oil, not compositional. So, and the type of well completion is going to be case oil, and we are not choosing any sand control. We have different types of sand control, but at this small point we leave it as none and then click done. At this point we can go to file, click save as, and to save our work, click save as, go to your desktop or create a folder on your desktop and save it any name. You can save it example1, 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 then double click it and save it as example plus x1 and click save. The next is to go to PVT data. Click PVT and click input data. Then enter your GOR to be 1200 and then enter your to be 39, gas gravity to be 0.8 and then leave it as default. You click on calculate your impurities, you leave it as default. Then click on calculate, enter the temperature, enter temperature from 200 to 200, 200 to 200, and steps 20 steps. The pressure from 3.5 to 3 on to 200, steps 20. Click continue, calculate your bubble point. Your bubble point is now 3000. Your bubble point is 4248, which is higher than your reservoir pressure. So now click on table to transfer this data to another window. But before then, here we have calculated the bubble point pressure, gas oil ratio, oil density, gas density, and water density. We have oil viscosity, water viscosity, and oil viscosity, and gas viscosity. All these ones are here. If you click on this, you see those things I've mentioned: water density, water viscosity, water formation volume factor, etc., etc. For now, we click main and then click match data, then click transfer, click yes, and then you click done, click regression to match your data, match all. Good. We click main and save our work. The next is to click on system, equipment, click all, edit. The first value is 00, the next is 10,000, 10,000, 9,800 through vertical depth. Click down, service equipment, we choose choke, and then under choke we enter 4 inches, and then we choose diesel, and then we enter the surrounding temperature 100, overall heat transfer 5, then we click done. Downhold, we choose tubing, the depth of tubing is 9,800, 9,500, 9,500, and 3 inches, and then we choose casing to be 10,000 feet, and then inner diameter to be 8. Then we click done. The temp formation measure depth 0, reference point temperature 50, 10,200. For the overall heat transfer 5. Then we click done. We click main. Save our code. Alright, click system again. Inflow performance. We choose Vogel. Vogel is used when the reservoir pressure is less than or equal to the bubble point pressure. But in this point, the bubble point pressure is higher than the reservoir pressure. So we are going to use the Vogel. Then we have here reservoir pressure to be 3,500, reservoir temperature to be 200, water cut to be 40%, and then we click input, test rate to be 5 2,100 flowing bottom hole pressure to be 2,900. Calculate, calculate. Now you have productivity index to be 3, and then you click main. The next is to click on calculation, 3 variables, wellhead pressure to be 3, and then we click on calculate or continue, calculate, calculate. So our oil is 2,050. So let's plot and see the performance of this well. So the well is flowing, and the point of intersection here indicates the strength of this well. So the flow, this is the flow, the operating point, the point of intersection is in flow in operating point, which is about 2,500. Solution note: we have oil rates here is 2,050. So this is liquid rate. Look at it here. The point of intersection here is the flowing bottom hole pressure against liquid rate. If you want to change it to oil rate, come here, change it to oil rate, and then you'll see that we have the exact figure here, which is 2,052 stop down barrel per day. So the natural flowing well is producing 2,050 stop down barrel of oil per day. So the well is flowing. The next equation or the next video, we are going to look at the well that is not flowing, or a dead well, a condition of a dead well. Thank you.